Jashan, co-host of the event. So recording is started. Uh, Now I'll also make Jashan co-host. Where is the option? Do you remember, Jashan? In participant.
I guess in participants there are three dots. If you click there, if you go to that rectangle participant box, there are three dots. If you click there, there may be visibility of co-host option.
Okay. I want to see if I'm the host. Okay, host
Yes,
is me. So yeah, it should record on the cloud. Okay, thanks, Jashan. Now, guys, as I said, I'm going to share my screen so that you can view a little message that is left by Sagun. So I'm sharing the entire screen, and let me know if you face any difficulties to hear the message.
ma'am, the audio is clear.
Audio is not clear.
Yes, ma'am.
Okay. Where is the meeting now? Okay. Is there a specific way to share this?
No, ma'am, still not audible, ma'am.
Not audible?
No, ma'am.
Okay, I'll do one thing.
Ma'am, I guess there is an option. If you share the screen, there is an option
Hmm.
for optimization for motion and video.
Okay, share the
I,
screen. Auto
I, I think,
texting
ma'am, that will solve
motion.
the problem.
Yeah. Okay, let me try. So this is a new platform that we are using this for this event. Generally, we use other platforms. That's why we are a bit. Screen. I don't have the option. I'll again start share screen and
तेरा दिख ही नहीं रहा तो मैं क्या करूं? यार बंद हो गया, छोड़ दे तू। नहीं लगाना, उसको नॉर्मल लगा देना।
Not audible now.
मेरा लैपटॉप खराब हो गया। चार्जर लाकर देखना। तूने देखा नहीं वही? क्या सिखा रही है वो? पता नहीं, अभी तक चालू नहीं किया। पर तू तो
No,
तेरे पास
not audible.
so that was Sagun from our end. Actually, he was describing. I know that there were some problems with the audio, but I would just briefly explain what he mentioned. He mentioned that Let's Excel Analytics Solutions was founded in September 2020. So it's been almost 2.5 years. We have started this business. We are a team of multidisciplinary experts. So, like, I'm from life sciences background, Sagun is from mechanical, and Jashan with us is from computer engineering background. And we are building solutions that will improve the business profitability and sustainability. We heavily rely on data analytics. That's why today's topic related to design of experiments is also from a similar domain, which is based heavily on the statistics. So that is a small introduction about us. Now, without further delay, I think we should start our topic. The main topic, it's about design of experiments. So please keep yourself mute unless you want to interrupt to ask a question, because audio is getting impacted. This is the first time we have moved to this new platform, and that is why it is also taking us a little more time to solve the problems. Okay. So before we begin the design of experiments, Let me first clarify that this is not an event where you will learn about what is factor, what is response, or why design of experiments is conducted in first place. So I would just like to get a feel of if you have this background about what is factor, response, and what is why you need to conduct a design of experiment. So I'm just throwing a question. Do you know what is a factor? And what is a response? Or maybe just simply raise your hand if you're not familiar with the concept of factor, response, or design of experiments, who is completely new to this topic. Is there anyone who is completely new to this topic of design of experiments? So I'm assuming everybody knows what is a factor and what is a response. So with that understanding, I'm just going to jump to the topic. So this is an Excel sheet. You will receive this Excel sheet. The purpose of today's webinar is to help you understand the calculations that happen in the background of any software that you're using. Because sometimes what happens is when we are sitting in a meeting room, you may feel that these are irrational results. Where are they coming from? This shouldn't be the output because you have some notions about the output because of maybe your scientific understanding as well. Sometimes the results may not match with your expectations, and you may be tempted to believe that there's no rationale behind design of experiments, but that is not so. There is a sound scientific rationale, there is a mathematics on the basis of which we interpret design of experiments. So this is only to prove that point, and this is only going, we are only going to discuss about full factorial design of experiments. We are not going to discuss about any other form of design of experiments. This Excel sheet will only help you understand the calculations behind full factorial design of experiments. As we know, full factorial design of experiments are used when we are going to have a screening experiment. When when do you say that you are at a screening stage? You say you are at a screening stage when you have not conducted more than 3 experiments. I would say like that. This is my own definition, because sometimes what happens is some people may come with prior knowledge of 40 experiments, and then they may expect that now I want to go for screening. If you have already conducted 40 experiments, you have enough data to directly jump to optimal designs or any other form of designs which will just help you fine tune your um, optimum results, so that it will give you maximum output from those results. So if you have already performed multiple experiments, it is not a good time to start full factorial design. Now um let's say we take an example of certain reaction, certain chemical reaction. I'm just removing this concentration just to make this problem a bit of generic. Can anyone please respond if you are going to plan a design of experiment for a chemical reaction, what kind of factors you will consider? Anybody? Let's make this interactive, otherwise it will become uh, really monotonous. I'll just speak to myself. Am I audible?
Yes, ma'am.
Okay. So Shatanik, if you are to experiment and you are planning a design of experiment for optimizing chemical reaction, what kind of factors you will give a thought to?
Operating temperature.
Sagar, any thoughts from your end? So I'm just noting down. I think I have some notes here. So I'll just,
Now concentration we can consider.
yeah. So I'm writing down the notes. I think it just disables the notes when I'm, okay, these are my notes. So note would be temperature, as Shatanik pointed out. And Sagar said that we can go for concentration. Neelkant,
Ma'am, the note screen is not visible at the moment.
oh my god. This platform is really,
It is showing the Excel sheet right now, but before that, it is
hmm,
showing the Gmail web page.
I'm stopping the share option and probably because it's from this platform only. So that's why. Let's go to Notepad. Easiest way. So temperature is 1 and concentration is 1. Neelkant, any input from your end? Are you there? Who are there? I think we have difficulty today. Yeah, Sagar, you want to say
Yeah,
something?
if pressure is there, we can keep pressure also.
Yeah, right. So I was looking for something that's outside Excel sheet because I want to explain a concept that is very important. So concentration, pressure, and also maybe time. So time we already have in um, our Excel sheet. Means time is already there, but pressure is not there. So what happens if you have a process parameter and which you cannot control? Let's say you have a vessel and you cannot accurately measure the pressure. You don't have a an instrument which can accurately measure pressure. So if you don't have that kind of instrument, what you can do, if you cannot hold a control of particular variable or a factor, what you can do is you can leave it aside. So if you leave it aside, what happens to the effect that particular thing produces? So generally, if we are speaking broadly, factor is always a cause. It causes something to happen. And response is actually the output you're trying to control. Now, this pressure is a cause that is affecting your, let's say, yield. Let's say your response is yield. And if your response is yield and this pressure is affecting your yield, but you don't have a way of controlling that particular yield, then what you can do is you can leave it aside and you can say that the cause, whatever happens to it during the process, if there is a cause uh, which I cannot control, which is beyond my control, and it produces certain effect. That effect we will call residual effect, or also this effect is known as random error. If you have this kind of random error, we call it natural variation of the process. And what we do about this, we simply accept this. We don't worry too much about this. We know that there will be some natural variation in the process, that we are going to accept. So if every day my environmental temperature is going to change, I have to accept it as a fact, as a natural variation. So for design of experiments, one of the assumptions that we make is residuals are randomly distributed. If you remember, there are some assumptions for design of experiments. That is a different, that's a background statistical theory, which will not get into that because then explaining the calculations will take longer. So take only understand this if there is some factor that we have not considered in our experiment because it is beyond our control. If you can control it, if you have a hold over it, then definitely you should include it in your design. But if it is not in your control and if you have excluded it, then it will be counted in the residual error. And how it will be counted, that we will see as we understand the calculations. So in this case, let's say हमने जो factors we arrived at, one was concentration, other is time, and the next one is temperature. So we said that we don't have control over pressure, so we have to sadly leave it apart, and we'll just conduct experiments with concentration, time, and temperature. We'll record the average yield. Now here the blank spaces are for your reading 1, reading 2, reading 3, reading 4, reading 5. And then you're summing these all 5 responses to get an average response. So when you're recording a response, generally that is a standard method anywhere in world. When if somebody is trying to experiment, and they're doing wet chemical analysis, they will perform replicate injections or some kind of a replicate run so that they can average out the response. And when you are analyzing the results by comparing with other experiments, generally it is the average response you deal with. You wouldn't deal with single point value with just single reading. You will take multiple readings and you will take average. Now what I have done is, I've not gone into the details of this blank, the single individual readings. I've just mentioned the average response here. Now these are like, let's say these are 1, 2, 3, 4, 5, 6, 7, 8. So these are 8 readings, and the question is why we have 8 experiments here. So the reason is, when we are saying that we have 3 factors, this concentration is one of them. This is 1, this is 2, this is 3. So if we have 3 factors, and I'm just trying to say one notation. Okay, it goes off. So this is, if we have 3 factors, and we want to experiment with 2 levels. 2 levels in the sense, if you are planning an experiment, if you want to see an impact of concentration on yield, what you will do? You might go for one experiment which is at high level and the other experiment which is at low level, right? So these are your 2 levels, high and low. So if you want 3 factors to be evaluated at 2 levels, what you will do, levels raised to factors. This will give you number of experiments that you need to perform. So this is 2 raised to 3. will be equal to 8. Any doubt here?
No, ma'am.
So this is how we calculate the experiments. अभी इसमें it's simple. This is at low level. Concentration is all at low level here. And then I have taken 4 runs at concentration high level. Then you have time at low level, time at high level. For low and high both. Similarly, temperature at low and high, temperature at low and high for every low and high value of your experiment. So these are different combinations you're performing simultaneously. Now next step is when you have found these 8 runs, you have performed all these experiments, and then you have also gathered the data of the average responses. Now you're ready to perform your calculations. How you will perform your calculations is like this. Here you will have, so this is your main effect. Is the screen properly visible? Because I'm going to describe the calculations now, so there shouldn't be any problem.
Yes, ma'am.
Yeah. So in this, let's say this is our first reactant whose concentration is very important to us. This is our low value, this is our high value. And how we are going to calculate the main effect. Now, what is the main effect? Main effect is, let's say we have now we have these 3 factors, isn't it? These are so we have 3 factors. One is time, temperature, and concentration. So we are going to calculate the main effect. What does a main effect means? If you have to rate something on a scale of 1 to 10, what will how much weightage you will give to each of these? So this is a broad way of explaining. Iska importance kitna hai? If you let me know if all of you understand Hindi, because
Yes.
sometimes I may
Yes.
casually so how important is this concentration? Can it change? It's like 1 to 10 के स्केल पे मैं बोलूंगा इसका importance 1 है. इसका let's say 1 to 10 के स्केल पे I can say that it's only 2. 1 to 10 के स्केल पे I can say this is only 3. So I can rank. So main effect is a way of ranking how much important this factor is, how significant impact it is going to produce, and how we do that mathematically. To do that mathematically, we simply um, let's say this is the low level of our concentration for the reactant, and what we do is we find out all experiments where the value of this reactant used is low, which is 3, and then we calculate sum of all those reactants, and then we average out sum of response for all those runs. So this is critical. Please pay attention. This is a formula in Excel. Now what it is saying, sum if, so this is your first row. It is going to throw a condition for this range B2 to B9. So which is that range B2 to B9 is the highlighted range. This one in blue color, B2 to B9. So it is saying that इस रेंज में try to find out this value B14. What is the value at B14? It's 3. इस रेंज में 3 को ढूंढ के निकालो. Find इस रेंज में इसको ढूंढ के निकालो और उसके अगेंस्ट जितने भी रिस्पॉन्सेस है उनका एवरेज बना लो. सो व्हाट इट विल डू, इसका सम बना लेगा. ये इसको whenever it will find that concentration of reactant is at 3, it will find out that cell in this average response. ओके तो लेट्स से अभी मैंने इसको फिल्टर कर लिया कहीं पे तो भी हाउ इट विल डू दैट मैन्युअली अगर देखें हम लोग क्या करेंगे वी विल डू इट फॉर सिंगल फैक्टर कैलकुलेशंस हम सिंगल फैक्टर के लिए करेंगे सो दैट आगे बहुत सारे कैलकुलेशंस है आई नीड टू एक्सप्लेन मल्टीपल कैलकुलेशंस तो एक एक फैक्टर के हम कर लेंगे एंड देन इफ टाइम परमिट्स विल गो फॉर रिमेनिंग फैक्टर्स सो इफ आई फिल्टर इट आउट फॉर 3 तो मेरा डेटा फिल्टर हो गया 3 के लिए I have all this 3.08. This is the response for all the runs that are run at low concentration of reactant H2O2. So what I will do, I will create a sum of them. So I will create this plus this plus this plus this. ये उसका मैनुअल सम मैंने निकाला फिर मैं इनको काउंट भी करूंगी ये कितने बार आया कितने रीडिंग्स थे अगेंस्ट द लो कॉन्सेंट्रेशन so there was one reading plus one more reading otherwise I can simply do if you understand this formula count I think filter won't work here वही problem है J2 to J5 okay so it will just count this 4 times आया this reading was there for 4 times so what it will do it will average out ये 30.74 को डिवाइड कर लेगा 4 से तो आंसर आएगा 7.6 so that's the exact answer we have got here but this is little more automated means even if you change the reactants even if you change the value and if you start using this Excel sheet even without making any changes it should work considering that हमने ये formula use किया है so that you don't have to replace anything so manually इसका calculation ऐसा आता है तो main effect का मतलब what is the main effect at low level main effect at low level is we cannot still call it main effect we can just say that effect at low level is 7.67 similarly we can calculate effect at high level matlab when the value is equal to 10 so again I'm going to filter this to show you manual calculations it has a similar formula for Excel so for manual calculation what we do simply again same thing हम लोग ये response का we will sum it manually this plus this plus this plus this so this is the sum again how many times it is there 1 2 3 4 so again 4 and what we will do is we'll divide this by this so answer is 14.8 same answer we got manual by automated formula which is like which will work without manual interruptions so these are the two values and what we need to do to calculate main effect is we need to subtract the value from the higher value lower value so if I subtract the response that I got for high concentration of H2O2 means if I subtract the response that I got for low concentration of H2O2 from the response that I got for high concentration of H2O2, then I get certain value. This value is main effect for that particular factor. So the main effect of concentration is 7.12. Similarly, main effect of speed is 4.63. And main effect of temperature is 4.34 so it is going to be like this it's will come to these calculations if you will have more doubts and what I'll do is meanwhile I'll also share this Excel sheet with you so if you're experimenting at your end you can also start you will also get your hands on it to come up with questions so Now let's see how you plot this main effects. Okay, so in main effects, how we go is, let's say this is your this x-axis. This is your plot for main effect, and this is your x-axis. It denotes the level of your factor. So what is the factor here? Factor is H2O2 concentration. So if it is changing from 3 to 10, so this is your 3 and this is your 10, low level to high level. And what was your effect when it was at 3? You can go up and see what was the effect at low and 3. Low, it was somewhat, I think I have to just, low it is 7.6, which is somewhere here, and high it is 14. So actually, if you draw perpendicular lines, you'll get to see the 7 and 14 values, and it will show an increasing trend. So if you are to interpret this kind of result, what could be your conclusion? What happens if concentration increases from low to high?
So response also getting increases, ma'am.
Yeah, so there is a direct relationship. If concentration is increasing, your response is increasing, your yield is increasing. And in all these three cases, time and temperature, it is saying that as your time is increasing, your yield is increasing. As your temperature is increasing, your yield is increasing. So we'll see these calculations if we are left with little more time after we finish all the calculations, because it's only 1 more hour left now. So any doubts so far? Any calculation which was difficult to understand?
No, ma'am.
Shatanik?
If we are having more than two levels, still the difference between the highest and the lowest level will give the main effect.
No. In that case, you have to calculate it separately. The difference between, for that level, you have to it has a different calculation. It's called center point. So we'll have to create a separate worksheet to explain that. Means you will do it the same way. What you will do is you will filter it for the midpoint, whichever you're, let's say you're running at a different one more level. You'll filter the data for that factor. You will have average response against that factor. Then you will sum up all those average responses, and then you will divide it by number of times you had a reading for that whatever response you had taken at a different level, and then it will give you the effect at that level. And maybe if, let's say, if you have, and it's important because center point has its own importance. Reason is, now you just had two levels, and let's say you had an experiment here somewhere, and it gave you result, it gave you a data point which is somewhere here. It gave you main effect. Now you calculated three main effect because you ran the experiment at three levels. So if you ran experiment at three levels, you will get three main effects. One is at low, one is at midpoint, one is at high level. And if your response comes somewhere here, that means it's not a direct relationship. It's actually a quadratic relationship. In this case, it was only a first order model. But if you get something like this, curvature is there, then it becomes a slightly different kind of relationship. So same way we can go on. Let's say if it's like you get it here straight on this line, then it's going to be the same conclusion. It's not going to change much for you. But somehow, if your midpoint has a effect which is somewhere above the equation for this line, then there is a curvature in your data. and then things get a little more trickier. Is this explains your question?
Yes.
Okay. Then we have interaction effects. Actually, we have really low turnaround because probably because it's a working day. This is the first time we are hosting an event on working day. Now this is one more interaction effect is another term that you'll see in your regular software. So what this interaction effect is? Now here, when you jump to interaction effect, you need to start coding. Coding in the sense you need to convert your low level and high level into -1 and 1. You can use any kind of indicator for that. You can also choose to have 0 and 1. You can also choose to have 0.5 and 1. It's just an indicator. But with -1 and 1, it's easier to calculate the low and highs for the interaction effect. Now, how you will do that? Now, this is the same experiments. These are the same experiments that were there. Here also, I think it's there. Yeah, they're present here, this side for reference. So if your concentration was at low level, I'll filter again. So if the concentration of particular reactant was at low level like this, and you decided to code low level with -1, so you will replace all the 3's in your experimental run with -1. Is this clear?
Yes, ma'am.
Okay, so what we are doing is we are renaming it. और वो एक फंडा होता है ना, आपका एक घर का नाम होता है और आपका एक बाहर का नाम होता है, वैसा ही है। इसका बाहर का नाम 3 है, बट इसका घर का नाम -1 है। सेम हाई लेवल के लिए विल गो 10. If it's on high level, we'll call it 1. तो इसका बाहर का नाम 10 है, घर का नाम 1 है। Now you will understand why we are doing this. अभी the question is, आपका अगर if you keep everything same, let's say आपने time same रखा, temperature same रखा और सिर्फ concentration change किया, तो आपका yield कितने % से बढ़ सकता था? Let's say you kept same concentration, same temperature, and you performed an experiment at concentration of 3 and you performed an experiment at concentration of 10, तो आपका yield कितने से बढ़ेगा?
Around 7-fold, ma'am.
Exactly. So 7.12 से बढ़ेगा. So in that case, what you will do is, it will be a straightforward thing for you. You will go ahead, but tomorrow you say that if I do something with the time or if I do something with the temperature, कुछ अलग experiment में मैंने इसको ये लिखा होगा speed. So if I play around with the time and temperature, I can get a better yield. So what I can do, I will change my concentration and I'll also change my time and I'll also change my temperature. But how do I estimate if I'm going to change multiple factors at the same time, how my yield is going to get impacted? So it is going to happen like this. बिकॉज हमने इसको 1 and -1 में कोड कर लिया है, अभी हम इसका मल्टीप्लीकेशन कर सकते हैं 1 and -1 का. लेट्स से इफ आई वांट टू फाइंड आउट कि मैंने मेरा concentration of H2O2 and the time I have changed at the same time, then what can happen? If I change concentration and time, together, what will happen is मुझे उसका interaction calculate करने के लिए I need to multiply this and this. So 1 multiplied by -1. Answer आया -1. Agreed?
Yes, ma'am.
1 multiplied by -1 -1. 1 into 1 1 आ गया. Similarly 1 into 1 again 1 आ गया. So this is a plain multiplication, but why we are doing it? Because we want to calculate what will happen if I change two factors at the same time. So two factors that I am playing with are H2O2 and time. So if I am going to change two, what will happen? If I want to see if I change all three, what will happen? मुझे यहाँ पे उसका multiplication करना है. So this 1 multiplied by 1 multiplied by 1, आंसर आया +1. इसमें एक -1 है, because of that it will come -1. Similarly in this we have 1 -1, ये -1 आया. It's yeah, -1 cancel out and it becomes a 1. So that's why iska multiplication 1 hai. So like this, we converted everything into high and low for combine effect as well. Concept समझ में आया?
-1 plus 1.
Any doubt?
Ma'am, what if we keep the same values without decoding them?
Then your answer will be variable. They will not be on the same scale. तो अभी हमने क्या किया, उनको स्केल ही एक ही रखा -1 to 1. अभी 3 to 6 and 25 इनको इवेल्युएट करने में हमको थोड़ा सा मतलब कि ये बड़ा है या छोटा है.
Okay,
It
ma'am.
can be very हाँ. तो अभी because we changed it to -1 and 1s everywhere. Now what we can do similar exercise. अभी हर किसी को filter करेंगे. अच्छा इसको filter करेंगे for filter. We'll filter this for low level. Interaction of concentration and time together on low level. ऐसे 4 runs निकल के आए. So these 4 runs what we will do? अभी क्या करना है? What is the step? कुछ thought process based on previous.
Calculate the same main effects.
मैंने बट ये अभी इंटरेक्शन हो गया. बट अभी हमको क्या करना पड़ेगा, इसको एवरेज कर, ये जो इसके रिस्पॉन्स आए. सो व्हाट हमने फिल्टर आउट कर लिया फॉर लो लेवल. ये व्हाट वी आर डूइंग इज वी आर हियर एट इंटरेक्शन H2O2X. We are at this interaction, and then what we are doing is लो लेवल पे कितने हैं वो फाइंड आउट किए runs. So 4 runs are on low level and all of them have, let's say this is the response that we got for each one of them. तो अभी हम क्या करेंगे, इसका सम कर लेंगे. How we will do that? मैन्युअली करेंगे तो ऐसे करेंगे, this plus this. ठीक है, सीक्वेंस डजंट मैटर. सो दिस प्लस दिस, ये हो गया सम. इसको एवरेज आउट करना है तो 4 नंबर्स है, 4 रन्स है, बिकॉज वी कैन विजुअली ऑब्जर्व देम. सो दिस डिवाइडेड बाय 4 11. तो आ गया 11.175. दिस इज द इफेक्ट of interaction at low level. Okay. Any doubts?
No, ma'am.
Okay. Same at high level. We'll run the same thing. We'll go through this. We'll say कि अभी -1 पे नहीं, 1 पे. So 1 पे what is the value we are getting? This plus this plus this प्लस दिस। ओके, ये आ गया 45। इसका फिर से हमको एवरेज निकालना है, दिस डिवाइडेड बाय 4। इसको एवरेज कर लिया 11.30। यही आंसर आया। इंटरेक्शन ऑफ H2O2 at high level 11.30, right?
Yes, ma'am.
Now what we'll do next step is we will calculate the difference. We'll simply subtract low level from the high level like this. We'll maintain the same sequence because later on you'll understand, if you are just to see the difference, if you are more interested only in the absolute value, you are not interested in knowing whether it is increasing or decreasing. Absolute value is something that matters to you. So right now we are just maintaining the same sequence of subtracting the lower from the higher, and we get a value of 0.1325. Okay, अभी इसका प्लॉट कैसे आएगा? इंटरेक्शन इफेक्ट्स का प्लॉट आता है. You'll see if you're are you using some software for design of experiments?
Yes, ma'am.
Which one?
Minitab, Design Expert, JMP. I have.
Yeah, very good. So now in this you see this interaction effect is there. 3 and 10 are concentration levels, right? 3 and 10 are concentration levels, and your x-axis is denoting the time. So what you are doing is you are plotting two lines. One is for concentration. So your x-axis will be essentially same for both the concentration readings, and you will note down the effect at low and high level there. So if you are going to interpret this kind of plot, what it means is, if you will see certain interaction like this, sometimes if you'll see, if you'll see a plot like this, then it means there is a significant impact of when two factors are interacting together. Means there is some intersection point. If these are not parallel lines, one factor is going to have an impact on the response that other factor is going to produce. So in this case, you'll see they're parallel. That's why they're not going to produce an interaction effect. Is this concept clear? Clear nahi hai. Okay. So I'll show you how this works. अभी ये 3 का series है. Horizontal category is your time. So time का axis आपका same है. Okay. Then you have readings for low level of 3. ये आपने इधर नोट डाउन कर लिया है. लेट्स से लो टाइम ये आपने सेपरेटली नोट डाउन किया. कंसंट्रेशन 3 था, टाइम लो एंड हाई था. कंसंट्रेशन 10 था, टाइम लो एंड हाई था. इन दैट केस आपका इफेक्ट क्या था, मतलब आपका रिस्पॉन्स क्या था, वो आपने नोट डाउन कर लिया. सो इफ योर रिस्पॉन्स वाज 5.4, 5.4 के पास आपने एक पॉइंट ले लिया, this point. Update. Okay, and then at higher second level, higher time, आपका response 9.9 था. So then you draw another point here. Similarly, at high concentration and low time, आपका response था 12.4. So आपने इधर 12.4 का एक point draw कर लिया. And at higher time, आपका response था 17. So you created another point. अभी आप उसको ज्वाइन कर दोगे तो ये ऐसा बनेगा. दिस इज व्हाट इज हैपनिंग. बट लेट्स से आपका अगर ये 17.2 की जगह पे रिस्पॉन्स वाज 2, 2 के आसपास है, कहीं पे नीचे एकदम 0 है, या लेट्स से 0 ही है, क्यों नहीं, 0 भी हो सकता है। सो इन दैट केस, ये हाइपोथेटिकल केस में आपकी लाइन ऐसे हो जाती थी। सो हाइपोथेटिकल केस में वो लाइन ऐसी हो जाती थी, इंस्टेड ऑफ गोइंग लाइक दिस इट वुड हैव गॉन लाइक दिस। So if the two lines are not parallel and are intersecting, then the interaction effect is significant. ऐसा आपको डिजाइन एक्सपर्ट में you will get this reading multiple times. ये आपको ऑटोमेटिक आंसर में लिख के आएगा, if you would have noticed. If you are still not convinced, इसको mathematically find out करने का भी तरीका है. So, if you are still not convinced, you can go for mathematical interpretation also. This is graphical interpretation. This is one way to understand if interaction effect exists or does not exist. But there is another mathematical option also. So, but still I would like to know if this concept is clear for you.
If it is clear, we can go forward.
Okay. Shatanik, do you have problems in seeing the screen or it's okay? You can see graphs?
Yes.
ये तो जशन. Shatanik?
Yes, ma'am. We can see the graph.
But on mobile, I'm wondering because I think some people have joined through mobile also, and then it may not be clear. Okay. Anyways, so we will move to, this was about one effect we calculated. It's going to be the same process for three-way interaction also, and it will be same for um four-way or multiple ways, any which ways you want. So the process is simply उनको scale कर दो, -1 and 1 में उनका multiplication find out कर लो, and जिसका multiplication -1 आ गया that is a low level, जिसका multiplication 1 आ गया that's a high level, and then calculate the difference between low and high. That will be your interaction effect. And graphically, if we are to plot that, you have to keep one axis common, and then you have to create, you can only graphically you can plot only two-way interactions, because we live in a, मतलब at least हमारे जो graphs होते हैं Excel पे, they're two dimensional, so you can go up to 2-dimensional. Now next step is Pareto. Have you heard about Pareto principle before?
Yes, ma'am.
What is it?
It is a ranking chart. Basically, we use
Yes.
in screen design.
Yes, it is definitely a ranking chart, and what it says is if you take care of 20% of the things that you want to have a good hold of, remaining 80% automatically get controlled. Means in a way it is saying that you try to control. Let's say if you are in a you are in a class and you are teaching a class of 100 students, and out of those 100 students, let's say 20 students are really naughty, the students who are kind of bullish in nature. So if you control only those 20%, remaining class you can control. This is broad way of understanding. So how you can apply that kind of Pareto principle in your day-to-day day-to-day research is like this. Now we calculated so many effects, and some of them were negative. In case of these specifically speaking, this time and temperature, concentration and temperature, they have come out to be negative. So what we do is, to calculate, to see the Pareto chart, we just calculate their absolute values. So these are the absolute values. For absolute, in the sense, it will just ignore the negative sign in front of that particular effect, and it will just convert it into its absolute value, positive value. Now in this case, if it is 0.4075 minus 0.4075 will get converted into 0.4075. So likewise, and what we do next is we arrange them in descending order. From after this is plotted, we simply say that rearrange this with descending order. So this is sorted. You can simply sort the data. You can use sorting option also. I have kept it as it is because I just wanted to show that it occurs in a in series of steps. First is you just calculate each effect like we calculated earlier, and then you convert it into absolute value. After it is converted into absolute value, you arrange it in descending order. Once it is in descending order, you can plot a bar plot like this using Excel. So if you look at the, actually we calculated total 7 effects, isn't it? Main effects for concentration, main effect for, so we calculated 7 effects: main effect for concentration, main effect for time, main effect for temperature, interaction effect for concentration and temperature. Any question?
No, ma'am, no.
Okay. So interaction effect for concentration and temperature, interaction effect for concentration, time, temperature, time into temperature, and concentration into time. So we discussed only 2 calculations because the calculation process is same for each factor. But total, in all, you can calculate 7 interaction effects. Now you have this 7 effects. Three out of them are main effects, and remaining are 4 are interaction effects. Now what you did is you arrange them in descending order like this. Now you can clearly see which ones are the real culprits. ये 7 बच्चों में से कौन से 3 ज्यादा शैतान है? कौन से हैं?
Yes, to concentration, time, and temperature, ma'am.
Exactly. So ये 3 हमारे. So this is a graphical way of your design, understanding design. You can say that कि इसमें मेरे 3 ही effects है जो important है. Remaining interaction effect are negligible. I can leave them out in my residual error. तो जो रेसिड्यूल एरर का मैं कंसेप्ट एक्सप्लेन कर रही थी, लेट्स से प्रेशर था, इफ हमारा प्रेशर होता और वो प्रेशर का इफेक्ट इतना ही आता, तो वी कुड से दैट कि दिस इज अ नेग्लिजिबल एंड इट विल लीव इट टू मदर नेचर टू मैनेज, ऐसे हम बोल सकते हैं. नाउ let's move on to next, ANOVA table calculation. Now this was about graphically analyzing the design. When you move on to understand how to interpret design using ANOVA table, here are some formulas. Again, what you will do is, in this case, your earlier calculated effects will be very useful. So let's say if you are calculating effect for factor A. Factor A is, let's say, concentration in our case. So what we'll do, how many number of runs we ran for, it's actually for dividing. This is applicable only for full factorial. This table, it's very complicated for other kinds of designs. So these calculations which are mentioned here are only applicable for full factorial. So what it will do, number of runs divided by 4 multiplied by a into effect square. तो अभी हमारे जो effect square है, let's say for concentration, if we are to find square of effects, how we will do, we'll have to ये तो मॉडल के हुए. for concentration, what we'll do is we'll have to go to earlier worksheet where we calculated main effects, है ना. यहाँ पे हमने main effects calculate किए, तो it will go to that main effects A2 to A9 divided by 4. And जो main effect का आंसर आया उसको, okay, this is actually number of runs, is actually how many number of runs we have ran, उसका total number of runs divided by 4, and then we are multiplying it by main effect that we calculated, उसका जो square है उससे. So what is this value? This was actually 7 point something. I'll go there and show you. ये है 7.12 है, ये जो वैल्यू आई है इसका स्क्वायर किया, और जो नंबर ऑफ एक्सपेरिमेंट्स थे, नंबर ऑफ एक्सपेरिमेंट्स डिवाइडेड बाय 4 से उसको मल्टीप्लाई किया. सो आई विल शो यू हाउ टू डू इट मैन्युअली, तो ये ज्यादा क्लियर होगा. ठीक है, नंबर ऑफ एक्सपेरिमेंट्स 8 थे, करेक्ट. टोटल नंबर ऑफ एक्सपेरिमेंट्स 8 थे, बिकॉज 2⁻³ is 8 divided by 4, because it's part of formula for full factorial design. So 8 divided by 4, again 1/2. Then what was your effect? You'll go here, ये effect आया था 7.12. I'm entering it here. What I'm going to do, I'm going to square this raised to 2. ये आ गया उसका आंसर. And then this thing multiplied by this thing, 101.60. आंसर वही आया, राइट, जो हमारा ये मतलब ऑटोमेटेड फॉर्मूला से आया था. इट्स अ बिट बल्कि फॉर्मूला है, इजीली नहीं समझ में आता है, इसलिए स्टेप बाय स्टेप मैन्युअली करके दिखाया. एनी डाउट्स?
No, ma'am.
ओके, सो this is how we calculate sum of squares. ANOVA table में you will always see sum of square का एक column will be there always. So it is this column. It is calculated like this. Okay. Now next step is finding the degrees of freedom. So how do we find the degrees of freedom? Degrees of freedom जो होते हैं, it's number of levels में आप experiment कर रहे हो -1. This is how you calculate. So if you are experimenting at 2 levels, 2 minus 1 is 1. तो आपका आंसर 1 आया. Now next step after you calculate degrees of freedom is you calculate mean square. मतलब ये sum of square को आप divide करते हो degrees of freedom से, उसका आंसर let's say in this case you have 1. So this value divided by 1, उसका आंसर है 10.60. Plain and simple.
Ma'am, can you repeat?
Yeah. So first is ये जो आपका sum of square था, this is there already, we calculated it. Then we have degrees of freedom. Degrees of freedom is number of levels you experimented at -1. So हमारे केस में हमने 2 levels में किया था, low and high. Number of levels were low and high. So they become 2. 2 minus 1 is equal to 1. So in this case हमारा degrees of freedom 1 है. मॉडल का डिग्रीज ऑफ फ्रीडम को मैं बाद में एक्सप्लेन करती हूँ. अभी आप सिर्फ मेन इफेक्ट H2O2 के ऊपर ध्यान दो. ये H2O2 का जो यार थोड़ा ना मैं कहीं और क्लिक कर रही हूँ और कहीं और हो रहा है क्लिक. ओके, सो H2O2 I am only I'll highlight it. I'm focusing only on this part now. H2O2 का कैलकुलेशन बाद में I'll show you degrees of freedom for model कैसे कैलकुलेट करने हैं. ओके समझ में आया?
Yes, ma'am.
So this divided by this 101 is the answer. Now we will go to F statistic कैसे कैलकुलेट करना है. उसके लिए पहले हम सारे टेबल्स के कैलकुलेट कर लेंगे पहले, मतलब सभी इफेक्ट्स एंड मॉडल का एक अलग से कैलकुलेट करना पड़ेगा. So this was first for H2O2. Similar process will repeat for time. Then we'll repeat it for temperature. H2O2 into time interaction effect. सबके लिए सबके degrees of freedom 1 आएंगे because we had two levels. Two levels थे इसलिए सबके degrees of freedom 1 आया है और सबका फिर mean square भी वही आएगा. Because anything divided by 1 is that number itself. Okay. ठीक है. यहाँ तक सब समझ गए?
Yes, ma'am.
Yes, ma'am.
अभी हमारा मॉडल बिल्डिंग का एक इटरेटिव प्रोसेस शुरू होता है. तो हाउ डज दैट इटरेटिव प्रोसेस वर्क? फर्स्ट इज हम ये सभी जो अभी तक के आए हैं टोटल सम ऑफ स्क्वायर्स इनका एक सम कर लेते हैं और ये टोटल में हम ऐड कर लेते हैं. अच्छा ये तो रेसिडुअल का है बट इट कुड बी और ओके. सो व्हाट वी डू ओनली जो मॉडल के हैं वो इसमें है टोटल में, बट टोटल नंबर ऑफ आपके जितने रन्स थे, मतलब टोटल नंबर ऑफ रन था 8. 8 में से 1 गया तो हुआ 7. तो टोटल डिग्रीज ऑफ फ्रीडम ऑफ टोटल मॉडल इज 7. ये फॉर्मूला है ऊपर दिया हुआ. नंबर ऑफ रन्स माइनस 1 इज टोटल. ये इटरेटिव प्रोसेस है. सॉफ्टवेयर जो है ना ये आपके लिए डिफॉल्ट से कर देता है. तो अभी हम ये मैन्युअली कर रहे हैं कि हम ये 8 रन में से टोटल नंबर ऑफ रन 8 माइनस 1 तो ये 7 आ गया. एंड व्हाट वी आर डूइंग इज ये टोटल का जो फॉर्मूला है ये सम ऑफ स्क्वायर ऑफ ए प्लस बी प्लस ए बी प्लस एस एस रेसिडुअल. एक्चुअली ये सभी का होना चाहिए टोटल का, बट ये यहाँ पे मैन्युअली एंटर करा है मे बी. नो इट्स डिफरेंट एक्चुअली. B15 to okay it's sum of the model plus residual because model में हमने जो factors consider किए उसका sum उसने it's the same thing actually. कैसे same thing है? If you'll add this plus this plus this then आपका एक आंसर आ रहा है which is matching to this total. करेक्ट है?
Yes, ma'am.
हाँ अभी ये जो 182 का जो आंसर आया है what you are going to do next is based on your Pareto plot you can say that मेरे तो 3 ही शैतान थे, मुझे 3 ही शैतान को कंट्रोल करना है. ये 7 फैक्टर्स के साथ I don't want to deal with. Then you will say I will add only three factors in my मतलब I count them as significant. बाकी को मैं थोड़ा सा नजरअंदाज करने वाला हूँ. So ये तीनों का जब आप समेशन करोगे सिर्फ because I am going to calculate my model based on only 3. So what I'll do I'll add them selectively. जो 3 मेजर शैतान है क्लास के उनको मैंने ऐड कर लिया, वो हो गए 82.41 which is same as model. करेक्ट? इनिशियली हमने हमारे पास कुछ बेसिस नहीं था तो हमने परेटो की अंडरस्टैंडिंग यूज की 3 इंपॉर्टेंट फैक्टर्स को सोच के. दिस कैन बी ऑटोमेटेड प्रोसेस इन योर सॉफ्टवेयर. डिजाइन एक्सपर्ट वगैरह आपको ऑटोमेटिकली 0.05 को इलिमिनेट करो, ऐसा ऑप्शन देता है। पी बेस्ड ऑन पी वैल्यू वी एक्चुअली क्रिएट अ मॉडल, बट रियल सीक्वेंस जो होता है मैन्युअली इन द बैकग्राउंड, इट हैपेंस लाइक दिस। इसमें आप पहले 3 मेजर शैतान को आपने खुद ही आइडेंटिफाई कर लिया है। सो दिस 1, 2 एंड 3, इनका समेशन आपका आ गया 182.41, एंड देन यू सेड मैं इनको ही मॉडल करने वाला हूँ, तो आपने 3 को ही मॉडल किया एंड यू सेड बाकी जो 4 है बचे हुए, प्लीज गो टू रेसिडुअल्स, रेसिडुअल एरर में चले जाओ। तो आज अगर आपका प्रेशर भी होता, प्रेशर वाज अ फैक्टर हियर, तो वो भी रेसिडुअल एरर में चला जाता, क्योंकि आपके पास उसका यू डोंट हैव अ वे टू कैलकुलेट इट्स इफेक्ट, तो वो रेसिडुअल एरर में चला जाता। रेसिडुअल एरर में चला जाता है मतलब इट इज नॉट इग्नोर्ड, इट इज स्टिल देयर इन द मॉडल, बट कैन वी कंसिडर इट एज अ सिग्निफिकेंट फैक्टर और नॉट, ये हमको पता नहीं। इवन इफ इट इज अ सिग्निफिकेंट फैक्टर, इट्स बियॉन्ड आवर कंट्रोल। तो कैन वी बिल्ड अ मॉडल विदाउट यूजिंग प्रेशर, ये फाइंड आउट करने के लिए इट वुड हैव गॉन इनटू रेसिडुअल एरर। तो अभी जो है ये 3 को ही इंपॉर्टेंस दिया है, 3 का ही समेशन फाइंड आउट किया एंड इट वाज दिस। बट मॉडल के डिग्रीज ऑफ फ्रीडम का जो फॉर्मूला रहता है, दैट्स डिफरेंट फ्रॉम अदर डिग्रीज ऑफ फ्रीडम। सो मॉडल के डिग्रीज ऑफ फ्रीडम में हमने 3 शैतानों को ऐड किया, इसलिए वो 3 शैतानों का समेशन इज डिग्रीज ऑफ फ्रीडम। करेक्ट, मतलब 1 प्लस 1 प्लस 1 3, क्योंकि इनमें से हमने लेवल्स माइनस कर लिए पहले एक एक बार, -1 -1 -1, तो इसका डिग्रीज ऑफ फ्रीडम अभी हुआ 3। एडिशन ऑफ द फैक्टर्स दैट यू आर गोइंग टू कंसिडर फॉर फाइनल मॉडलिंग, उनका जब आप समेशन करोगे, इट हैज कम डाउन टू 3। Now what you are going to do is, now you are going to calculate mean square. Now in this case, since it's not 1, your effect will be divided by 3 and उसका mean square का value कुछ आएगा, it will be different than your sum of square. It is reduced 3 times, approximately 60 आ गया। ठीक है,
Yes, ma'am.
तो बाकी के बचे हुए जो 4 शैतान है, दे आर ऑल गॉन इनटू रेसिडुअल्स। रेसिडुअल का भी हम सम ऑफ स्क्वायर कैसे फाइंड आउट करते हैं, रेसिडुअल के लिए जो हमने इंक्लूड नहीं किया मॉडल में, दिस प्लस दिस दे आर ऑल एडेड। तो उसका जो सम ऑफ स्क्वायर है वो आया 0.48, विच इज हियर बाय यूजिंग फॉर्मूला इनसाइड द टेबल। Because they are not included in model, we are calling it as a random error, we are calling it as a natural variation, and we are accepting it. Everything has flaw, तो हमारे मॉडल में भी कुछ फ्लॉ है, वो फ्लॉ हमने एक्सेप्ट कर लिया। वी आर सेइंग रेसिडुअल एरर इज ऑलवेज गोइंग टू बी 0.48। now what is the degrees of freedom for residual error? It is equal to summation of factors that were not considered in building model, तो वो होगा 1 + 1 + 1 + 1 मतलब 4, बिकॉज टोटल हमने 4 मॉडल्स नहीं कंसिडर किए। अनदर वे टू लुक एट इज कि आप टोटल डिग्रीज ऑफ फ्रीडम, मॉडल के डिग्रीज ऑफ टोटल डिग्रीज ऑफ फ्रीडम में से माइनस मॉडल के डिग्रीज ऑफ फ्रीडम, इट विल ऑल्सो गिव यू सेम नंबर 4। 7 - 3 is 4, because remaining 4 were not calculated for the final model. We are going to keep them outside to make things simpler for future predictions. जैसे हमने इसका सम ऑफ स्क्वायर निकाला, इसका डिग्रीज ऑफ फ्रीडम निकाला, अभी हम उसका मीन स्क्वायर भी निकाल रहे हैं। ओके, सो मीन स्क्वायर आ गया 0.12। अब This is the critical step. आपका जो p value है, it depends on all this, like which factor you are including in your final DOE interpretation will decide your f statistic and p value, because आपका आगे का सारा गेम जो है, it is dependent on the residual error and the main effect which you calculated for that particular factor. So let's say आपका अगर H2O2 है, so H2O2 के केस में main effect divided by residual error. So let's say अभी आपका pressure का example लेते हैं. We have not included pressure in our DOE. It is in our let's say it becomes a part of our random error. Even if it is not mentioned, when something you can't account for, it will automatically counted as error. और जब वो error हो जाता है, it will automatically reflect in your residual error somehow in calculations. So let's say ये जब आपका main effect है, it is now 101.60. मीन स्क्वायर जो है आपका 101.60 है, विदाउट कंसिडरिंग प्रेशर. अभी आपका रेसिडुअल एरर जो है, बिकॉज यू हैव नॉट अकाउंटेड फॉर वन फैक्टर, यू हैव नो वे टू कंट्रोल इट. आपका अभी जितना रेसिडुअल एरर आया है डेसिमल्स में वैसा नहीं आता है. लेट्स से इट कम्स आउट टू बी 200. इफ इट कम्स आउट टू बी 200, व्हाट विल हैपन इज, इसका रेशियो व्हेन यू विल टेक 101.61 divided by 200, it will be approximately 0.5, isn't it? So your f value will be very small, which is very contrary to current position. इस केस में आपका f value is low because your जो residual का mean squares है, it's very low, it's in decimals 0.12, and you're dividing your mean square by that low value. So that is why you are getting high f statistic. So f statistic is nothing but it's actually your variability within samples divided by between samples. So if between sample variability is high and within sample variability is low, then this decimal value will be equal to low. But if your within sample variability is high and between sample variability is low, then this will be high. And when your f statistic is high, that means the two groups you are trying to compare are different. They are not same. If you are aware of null hypothesis, एक concept होता है statistics में. Null hypothesis में what it says is there is no difference between इसका मतलब क्या है, सब चंगे हैं. आप टेम्परेचर चेंज कर दो, आप टाइम चेंज कर दो, यू चेंज एनीथिंग, concentration change कर दो, there is no difference. If you believe this, then you say this is my null hypothesis. But जब आपका f value high आ जाता है, it means between groups is higher than within groups, and when the between groups is higher than the within groups, तो इनमें तो बहुत फर्क है. So that point gets highlighted statistically. So f value is a way of arriving at a conclusion statistically or based on a number. So Pareto में हमने थोड़ा सा graphically we went on, but in case of f value, it is reflected numerically. So if your f value is 0.44499, which is very high, you can see that it's a high value. So then higher than, इसका भी एक फंडा है कि how much high is high and how much it is actually decided on the basis of p value, which p value you want to keep, what kind of rejection criteria you want to set for your samples. If you want to be very stringent, you will set a higher p-value, 0.1, 0.2, 0.3. If you want to be little lenient, you can keep smaller p-value. That's a different discussion altogether. But now, so F statistic आपके इतने सारे आ गए. So this is, I have numerically written the results here, because every time the results, we have to go to different chart to find out whether it is significant or not significant. So that's why this is only written in words here. And I'll show you how you can comment on whether it is significant difference or not significant difference. But for time being, understand that everything that has a high value, F statistic, is significant for the model. So as anticipated from Pareto chart, a concentration, time and temperature are significant, and they are highlighted as significant because we are able to build a significant, the F statistic for model also is significant, since model is significant. Similarly, if we look at these values, interaction values, they are very less in magnitude as compared with the other values like model, H2O2, time, temperature. So that's why we have not called them as significant. Clear until this point?
Yes, ma'am.
Okay, so I'll just move to describing how this p-value can determine whether it's important, significant है या नहीं है. So this is actually F distribution table, and we can keep p-value. So p-value is threshold at which you would like to reject the null hypothesis. So let's say you decided I want to reject the null hypothesis if my value is, this is a
Ma'am,
very common
ma'am, we
case.
are unable to see your screen.
Oh yeah, okay. तो मीटिंग विंडो दिखा रहा है. Okay, so this is the table. F table होता है ये, and इसमें when you are going for auto selections, you will see that auto selection in design expert gives you option to select your p value, eliminate from the model if p value is less than 0.05, or less than नहीं होता है generally, higher than 0.05, and then it automatically eliminates the samples which will have values which are higher than 0.05. And it will come up with a model. It will calculate its mean square, its degrees of freedom, and everything for you based on the p-value. So p-value is nothing but the threshold. It is a threshold that you decide for yourself. Usme bhi things are there, like if you are coming from a supplier end or if you are coming from a buyer end, on the basis of that you can decide whether you want to go for high p-value or low p-value. But that is a discussion for another day. For time being, understand that if you decide a p-value of 0.05, which is normally stated in almost blindly, stated in almost all literatures. So if you go with that p-value of 0.05, which is mentioned here, I wish I had highlighter instead of this. So this is 0.05. P of 0.05. Can you see the highlighted value?
Yes, ma'am.
Point. And now we are going to again see the degrees of freedom. So हमारे केस में क्या था? How many degrees of freedom were there? Total degrees of freedom. So they were 7.
7.
Total. So this is 7 here, right? And this is actually, this F distribution table is nothing but it's used as a standard, you can say, reference. These are available behind every statistical book. If you purchase any statistical book, they are available. जैसे आपका molecular weight का वो Merck index रहता है, kind of. So this is a kind of, that kind of distribution table which is generally available at the back of pages. Now this is your 7, and for the degrees of freedom for the numerator actually. So हमारा जो numerator है, it is the number of terms that were included in model. So instead of 7, what we need to see is 3. We included 3 terms because there were 3 demons. 3 demons को include किया था in the numerator. That's why 3. मॉडल के कितने हैं? मॉडल के 3 हैं डिग्रीज ऑफ फ्रीडम. सो 3 दिखाती हूँ. ये स्क्रीन, डिफरेंट स्क्रीन विजिबल नहीं होता है फिर बाद में ना. So if, let's say we are calculating this for model only, is this Excel sheet visible now? Or you are still seeing the distribution table?
Only we are seeing distribution table, ma'am, not Excel.
Distribution table.
Okay. So nothing, what it, I'll revise the calculations here because it is sharing one thing at a time. So we have this model के degrees of freedom थे 3 because we included 3 people, 3 notorious people in the model, and total residual के मतलब total जितने थे, they were 7, right? Total degrees of freedom जो last में आए थे. So हमारे जो numerator है, numerator में आएगा 3, and actually it should be like 4. Let me clarify एक बार देख लेती हूँ. F statistic के okay, हाँ, numerator में आएगा 4 actually, not 7, because total थे 7, total number of experiments 8. 8 minus 1 मतलब 7. Total degrees of freedom 7. We included 3 in model, and remaining which were not included in model are 7 minus 3, which is equal to 4. And when we calculated F statistics, we divided this within sample variation by between sample. W by B, I'm just indicating for simplicity. So if it was W by B, so that means if we have 2 groups, the ones which are included in model and the ones which are not included in model. So the ones which are included in models are 3, and the ones which are not included in model are 4. Isn't it? So numerator में आपके 3 है और denominator में आपके 4 है. So what you will do, you will move to 4. You will move down in this chart. यहाँ पे 3 है, and if you go slightly below, यहाँ पे 4. Now you need to find out intersection of these two for p value of 0.05. यहाँ आया. So this is the value at interaction. कितनी आई है? 6.59 आई है. Okay. What is this? It is a critical value. क्रिटिकल वैल्यू का मतलब क्या है कि 6.59 आपका अभी इधर I'll just reshare. Just remember this value we have arrived at. We have arrived at 6.59. I'll reshare the screen. Okay. I just forgot 6.59. So critical value was 6.59. Okay. अभी हमारा यहाँ पे F statistic कितना है? 4.99. If the way to tell if something is significant or not significant, and this is a usual misconception that everyone has in our research articles, everybody will say that since the value of p is less than 0.05 it is significant. Since it's not that case. What happens is it's the other way around. You decide the p value first. हमने पहले p value fix की है. P value was fixed to 0.05. So we said कि we want to fix the p-value for rejecting null hypothesis and it was 0.05. If it is आपका अगर ये जो है 6.59 जो critical value है 6.59 is greater than this value 499.37, in that case you can say that there is no difference in those two groups. Means the samples which are excluded, samples which are outside your model, and the samples which are inside your model, samples in the sense observations. The observations that are inside your model and observations that are outside your model have no significant difference. If this was greater, आपने null hypothesis accept कर लिया होता. मतलब fail to reject the null hypothesis, the common term. और फिर since this is less than your 499, means this is not the case, this is the wrong case. ये मैंने सिर्फ पिक्चर के लिए दिखाया है, वो वैसा है नहीं. This is the right case. This is the case. This is actually what we are observing. 6.59 is less than 499.37. So that is why we say that इसमें difference है. They are not the same. The samples that are outside your model are not going to have a significant impact as compared to the samples that are inside the model. And there is a strong evidence that these are the three factors which are having significant impact on your response, which is yield in this case. So this process has to be repeated similarly for your main effect of H2O2. So what you will do is, again, I'll change the share content. इस केस में 1/7 होगा. So न्यूमरेटर D16, इसका डिग्रीज ऑफ फ्रीडम है 1. No, इसका 1/4 होगा इस केस में भी. So we'll go because how corresponding degrees of freedom 1 है for this second F statistic and its denominator का corresponding degrees of freedom 4 है. Okay? तो इसके लिए we'll again go share content. किधर है मेरा? Can you see the screen now? F table. Is F table visible?
Ma'am,
Shaifani?
it's F critical value showing, ma'am.
Okay, okay. Yeah. So that's what I wanted to ask if like yeah. So our
Can you
numerator
zoom
is
a bit?
1. Zoom. Okay. So okay. इतना zoom ठीक है या you need more? This one should be okay, I think. Okay, anyways, so I'll move to for calculate one and we want to calculate it at a threshold of 0.05. उसका critical value क्या है? We want to calculate at threshold of 0.05. So we move to the 4 denominator हमारा 4 है. So 4 डिनोमिनेटर के लिए 0.05 थ्रेशोल्ड के लिए 7.71 यहाँ पे इंटरसेक्ट हो रहा है वो दोनों 1 डिग्रीज ऑफ फ्रीडम एंड 4 डिग्रीज ऑफ फ्रीडम 7.71 पे इंटरैक्ट हो रहे हैं सो व्हाट वी नीड टू सी इज वी नीड टू सी if 7.71 is greater than the the sum mean square effect. So here we have mean square. Sorry, F statistic is greater than the critical. यही हमको evaluate करना है. So F statistic is 834, which is far greater than 7, approximately that value which we got 7. So therefore it is significant, and that's why we have this interpretation as significant here. So this is how we calculate um, whether something is significant or not significant, because we are already close to 5 o'clock. I would like to quickly ask if this concept is clear so that we can conclude the session.
Yes, ma'am.
Okay. Chalo then, guys. If any doubts are there, you can get in touch with us. Even Jashan will now explain in a bit like how you can connect with us if there are any problems. So with this, if you have more questions, please ask anybody if have questions. So I'm assuming there are no questions, and I will hand over to Jashan to conclude the session. Okay, Jashan, you can take up. I'll just share the screen. No, I'll make you the presenter.
Okay, ma'am.
Or you, do you want to change the? Yes. So I'm making you the presenter now.
Ma'am, is my screen visible?
Yes.
So thank you guys. I hope everyone enjoy the event. We hope we really make your time worth and clear the concept of DOE for you. But wait, we have something more exciting for you. So we bring some valuable resources for you. Everyone who has attended the event will be provided with the attendance certificate, which will be contained as a proof of attending the event. Webinar recording and the respected slides will be shared with you so you can access the whole concept of DOE again anytime and anywhere. We will also provide you to access to Data Pandit so you can access our data analytical SaaS tools. Uh, Also, we will provide you the DOE Excel sheet soon. We will also have a website forum for you so you can discuss and clarify your questions with us. And we will be also provide you with our discounted ebook on Kindle. As we guys have spent a quality time today, we have something more for you. Since you are interested in DOE, we will offer you some applicative courses which will help you to pursue a great help in your research with up to 60% off. So you will get the linear discriminant analysis course, principal component analysis course, partial least square, principal component regression, and multiple linear regression. And there is also a special offer for you guys. Uh, if you purchase our all 5 courses, we will give you at least 65% discount per user. Now for claiming the reward, please mark the attendance in the Excel sheet we will share you soon. Thank you and make most from your data.
Thanks, Jashan. I think we'll just share the link here in the chat box for marking attendance. Okay, anyways, it seems I can do it here itself.
So guys, I have shared a Excel sheet for attendance. Kindly fill up the forms so we can send you your rewards as soon as possible.
Where is it shared, Jashan?
Ma'am, I have shared in the chat box.
Okay, I'm seeing a different one. Yeah, it's actually Google Sheet. You can mark your attendance, and if you're interested in any courses, you can let us know. It was nice talking to you all today, and it's a pleasure to be of any help in future. Thank you so much for your patient listening. Please keep in touch.
Thank you, ma'am. Sir, actually, we are unable to click on this Excel sheet.
Okay. So Sagar, you're attending alone or you have a class there with you?
Actually, initially we wanted to attend with class, but due to these weekdays, we were unable to, get together with other papers.
Okay.
So
I
I'm
think
attending
it's
alone.
okay.
But when I'm opening this sheet, now I'm unable to click that.
Yeah, even I am seeing it. Probably because of some access.
Ma'am, I am again sending the sheet. Try this one.
Okay.
Actually, what I'm saying is you can only view these documents.
I have
Access.
Editor level.
changed some privileges settings. You can try it again.
Okay. Thank
Yeah,
you.
it's
So
working
I
now.
think,
Thank you.
yeah, thank you. If you can access, that's really good. So if you have any doubts, please stay connected. Sagar explain to the other people in the class
Sure, ma'am.
and
Sure, ma'am.
help them grow their knowledge, and we'll surely get in touch soon.
Sure, ma'am. Thank you.
Okay, welcome. Chalo. Shall we close the meeting now? Okay, we'll conclude the meeting. Keep in touch. Thank you so much for being here.